This topic will be about solving logarithmic equations, and as the name suggests, these will be equations that have logs in them. Particularly, we're going to talk about the type where there's only one log and the rest are just regular numbers. Now, conceptually, there are two schools of thoughts, or two different techniques on solving logarithmic equations, and they only differ based upon concepts. They achieve 100% the same. So I suppose you can say in practical terms it's not important to know the differences, but I think, conceptually it's really good to know the two different schools of thoughts. One school of thoughts uses the pure definition of what a log is. So recall that if you have a logarithmic expression, log base b of some argument equaling x, what does this really mean? That means x is the exponent on base b that gives you an argument or an answer of a. So one technique of solving logarithmic equations is to transform him into an exponential equation, which you can then hopefully solve easily. The other school of thought is exploiting the fact that exponentials and logarithmic functions are inverses of each other. So recall that if you have an exponential base raised to a log base of that same number, that they sort of quasi-cancel out, leaving you with the original argument. So these two techniques will achieve the same goal, rewriting an exponential form. It's just different philosophies. So convince your mind however way you want, you will achieve the same goal. But those are the only tools that we need to solve logarithmic equations. For instance, we'll start off simple and then I'll try to make it more complicated by adding extra numbers, but it really does not get any more complicated than this. For example, let's say I wanted to solve, say, log base 8 of negative 2x minus 4 equaling 0. Oh heck, this is, let's just solve this. I was gonna choose a different example because 0 is sort of boring, but we'll work with this. So, to solve this, well, let's use the first school of thought. The first school of thought says, okay, notice what we have here. We have one log equaling one number. That is just the same format as this guy. One log equaling one number. So we can transform him into exponential form. So let's go ahead and do that. So if I were to transform this guy into exponential form, what would we have? This statement says 0 is the exponent on 8. That gives us an answer of negative 2x minus 4. Now what we've done is the variable that we're solving for x is no longer trapped inside of a log. It becomes a regular freed variable that we can then freely solve for. 8 to the 0 power is just a number, specifically 1. And then this gives us an easy peasy linear equation to solve. Add the 4 over 5. And then divide out the negative 2. And there we go. X equals negative 5 over 2. Okay. So that's basically one way to solve logarithmic equations. Just utilize his definition, convert it into exponential form, so you can then solve for x. The other school of thought uses the idea that logs and exponents are inverses of each other. This technique is called exponentiation. Now, you don't need to know what it's called, but that's basically what we're going to be doing here. Is we're going to use exponents or exponential bases to our advantage. For example, suppose I wanted to solve log base 5 of 7x minus 1 equaling negative 2. So we could use the same techniques as before, but I want to show you both. So here's the logic. Okay, Algebra 101, solving for x. You need to isolate him. Here's our x here. But x is trapped inside of this parentheses. This parentheses so happens to be an argument of this log. So before I do anything, I need to get rid of the log. So this is the question I ask myself. Gee, what is the inverse of a logarithmic function? And of course the answer is an exponential function. Well, in order for things to cancel out, according to the idea, the bases need to be the same. So if I want to get rid of this log base 5, I need to use an exponential base of 5. So we're going to exponentiate both sides using base 5. Essentially what it means is you take the original equation, the black, and we're going to push them upstairs into exponents. We basically transform the original equation into exponents on top of a base 5. Now why did I choose 5? Well, because now on the left hand side, 5 raised to a log base 5, these guys cancel out, and we're left with 7x minus 1 equals 5 to the negative 2 power. It is 100% the same result as if you converted it into exponential form, but it's technically using a different concept. So however you want to convince yourself, basically you want to get rid of the log by converting it into exponential form. And then you just solve it like normal. 7x minus 1 equals, this guy right here is 1 over 25. Let's add the 1 over. So that's 26 over 25. And then let's divide both sides by 7. So if you divide both sides by 7, 7 quarters is 175? Yeah. There we go. Easy peasy. So that's basically the idea to solve logarithmic equations. Once you have one log equaling one number, you go ahead and get rid of the log either by exponentiation, right concept, or by converting, left concept, and then you just solve. The only way that this can get, quote, harder is if I added more stuff to the equation. But it just means you have more steps to do. It does not change the problem-solving process whatsoever. So let's see. Let's try to make this as super-duper ugly as possible, which I really can't. Suppose I ask you to solve negative 6 plus 3 times log base 4 of negative 2x plus 5 equaling 0. What would be our plan of attack? We'll do note at the very beginning. All of our concepts will only work if we have one log equaling one number. So that's sort of your goal. If you have a logarithmic equation and it's filled with messy numbers and everywhere, your goal is to get the log by itself. You do not want to do anything until this log is isolated. So I hope it's very clear to everyone that to get this log by itself, we need to get rid of the negative 6 and we need to get rid of the 3. Well, to get rid of the negative 6, we're going to add 6 to both sides. And then to get the log by itself, to get rid of this 3, we're going to divide both sides by 3. Then it becomes just like the previous examples. Solving for x, get rid of the log. You either exponentiate both sides with base 4, or let's just go ahead and use the definition. What does this sentence say? It says 2 is the exponent on base 4. That gives us an answer of negative 2x plus 5. And then you just solve it like normal. So this is 16. Let's go ahead and subtract 5. And then divide out the negative 2. So there we go. X equals negative 11 over 2. So that's basically it. That's how you solve logarithmic equations of the form log equaling a number. First, make sure the log is by itself. And then once the log is isolated, convert it to exponential form. And then after you convert it to exponential form, you just solve it like normal.